You could pick the wrong model and burn through your budget in a single weekend. Kimi K3 is the open-weight model out of Moonshot AI that undercuts OpenAI on price by a wide margin. GPT 5.6 Soul is OpenAI's most expensive, most capable flagship, built for serious reasoning and coding work. The numbers on a leaderboard don't always match what happens to your actual bill or your actual deadline. 5 tests, 1 running scoreboard, and a decisive verdict settle which one actually earns a spot in your workflow. Test 1. Cost. Run any real coding workload through one of these models on a regular basis, and the price difference shows up on your card fast. Kimi K3 lists at $3 per million input tokens and $15 per million output tokens, blending out to around $2.30 per million total. GPT 5.6 Soul lists at $5 in and $30 out, blending to about $4.35 per million. That puts Soul roughly 47% more expensive on the raw rate. On the deep SWE benchmark tracked by Together AI, Kimi K3 solved 14.7 tasks per $100 spent. GPT 5.6 Soul solved 5.3 for that same $100, close to 3 times less finished work. That's not a small gap. Drop a comment if that cost gap matches what you've seen on your own token bills. That's test 1, and it makes Kimi K3 the winner, putting the score at 1-0 in Kimi's favor. But the number that actually matters is what happens when you point both models at real coding tasks instead of a spreadsheet. But a cheap model that can't finish the job costs you more in wasted attempts than the expensive one ever would, and that's exactly what test 2 checks. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. Test 2, Coding Benchmark Performance. A lot of people glance at a leaderboard and call it a day, and that's how you end up trusting the wrong model on the wrong task. On that same deep SWE benchmark from a July 2026 Together AI run, GPT 5.6 Sol wins the single-shot answer, 72.7% to Kimi K3's 68.5%. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. With only one attempt, Sol pulls ahead by a real margin. Let the model retry though, and the picture flips. Pass at 2, meaning solved within 2 tries, puts Kimi K3 at 82% against Sol's 81%. Pass at 4 pushes Kimi to 89.4 against Sol's 85.8. On raw consistency, meaning how often each model nails the same task every time across 4 runs, Sol holds the edge at 84.5% versus Kimi's 76.6%. On the broader intelligence index that rolls this together, Sol scores 61 and Kimi scores 60, close enough that calling it anything but a tie would be dishonest. Sol reached its single-shot answer far faster than Kimi got to its own, and that speed gap is exactly what Test 3 settles. Test 2 goes to nobody, it's a tie, keeping the score at 1 win for Kimi, 0 for Sol, 1 tie. Test 3, response speed and throughput. This matters most if you're running a long agent session or generating a big chunk of code and sitting there watching the cursor crawl. Benchmark data from artificial analysis puts GPT 5.6 Sol at 66.4 tokens per second against Kimi K3's 42.8, so Sol generates roughly 55% faster once it gets going. The same benchmark provider measured the previous generation the same way, GPT-5 against Kimi K2, and GPT came out faster there too, which makes this a repeat pattern instead of a fluke in one test run. That said, it's still one source. Treat the exact number as directional, not settled fact. Test 3 goes to GPT 5.6. Sol, evening the scoreboard to 1 win apiece with 1 tie standing. But raw speed means nothing if the model can't hold your whole codebase in its head to begin with. And that's the next test. Stick with me. because the last 4 tests are where this decision actually flips. Test 4, Context and Output Limits. This decides whether you can load a full codebase or a long document into the model without getting cut off halfway through, or quietly triggering a bigger bill than expected. On the raw numbers, these two are basically tied. Kimi K3 supports around 1,048,000 tokens of context, with a max output of 131,000 tokens. GPT 5.6 Sol sits at roughly 1,050,000 tokens of context, with 128,000 token max output, close enough to call a wash. But there's a detail buried in Sol's pricing that changes the math the moment you use that big window, and we're coming back to that shortly. For now, Test 4 is a tie. The score sits at 1 win each, with 2 ties on the board. The biggest gap left between these two comes down to whether you can even run the thing yourself, and that's the whole point of Test 5. Test 5, Deployment and Modality. This matters less on day 1 and more the day your vendor changes pricing or cuts your access, and you realize you can't move. Moonshot AI released the full weights for Kimi K3 on July 27, 2026, open for anyone to download, modify, and run on their own hardware. GPT 5.6 Sol stays completely closed, with no weights to download and no way to self-host, so it's API or ChatGPT access only. The honest hedge here is that open weight doesn't mean free to run. Moonshot's own recommended setup for K3 calls for 64 or more accelerators and roughly 1.4 terabytes of raw weight storage. So most people watching this will still reach for a hosted version of Kimi 2. Both models are natively multimodal this generation, though Sol inherits OpenAI's more polished consumer suite for voice, image, and video. Still, the ability to self-host at all is a structural difference GPT categorically can't match, so Test 5 goes to Kimi K3. Final scoreboard, 2 wins for Kimi, 1 for Sol, 2 ties. Here's where that leaves each one. Kimi K3 took costs by a wide margin, nearly tripling the completed work for the same $100. Tied the coding score once you average it out, tied context and output limits, and 1 deployment since it's the only one you can put on your own hardware. GPT 5.6, Sol, took speed outright and still owns the single try coding number, which makes it the model to reach for when you only get 1 attempt at the answer. Now, here's where that leaves each one. Kimi K3 took cost by a wide margin, nearly tripling the completed work for the same $100. Tied the coding score once you average it out, tied context and output limits, and 1 deployment since it's the only one you can put on your own hardware. GPT 5.6, Sol took speed outright and still owns the single try coding number, which makes it the model to reach for when you only get 1 attempt at the answer. So this settles the actual use case question. If you're running iterative or agentic coding work, the kind where the model gets to retry and cost adds up fast across volume, pick Kimi K3. That per task economics compounds every day you run it. If the work is one-shot, deadline sensitive, or needs the fastest raw output alongside a more polished multimodal product, pick GPT 5.6. Sol, still not sure which bucket you're in. Default to Kimi K3 as the safe pick, since it's competitive or tied on 4 of the 5 tests here, while costing roughly half as much on the numbers that actually move the needle. The one exception is when speed or single-shot certainty is the entire job, and then Sol earns its price. One thing the docs don't spell out, remember that big context window on GPT 5.6. Sol crossed 272,000 input tokens, and OpenAI reprices the entire request, not just the tokens past the line, at double the input rate and 1.5 times the output rate. Stack that with fast mode pricing, which doubles it again, or a regional endpoint surcharge on top. The worst case on Sol runs close to 4 times the sticker price quoted back in Test 1. There's a video that pushes this pricing gap even further. Once a third model gets thrown into the mix in Claude Opus versus GPT 5.6 Sol, which one actually codes better, the verdict changes all over again.